Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, so for this task that we're going to do today, a little bit of a departure from CPM. This is just one of those math tasks where it gets us thinking about ratios and proportions and, scale factor, and sort of a kind of a way it is related to all of this. So let's just do this for our Wednesday activity. Here are the directions. It says students in Ms. Bacca's art class were mixing yellow and blue paint. She told them that two mixtures will be the same shade of green if the blue and the yellow paints are in the same ratio. So here is a table of 1, 2, 3, 4, 5, 6 different mixtures, all labeled as A, B, C, D, E, and F. And it shows you on the side how many parts of it are yellow, how many parts are blue. So the table below shows the different mixtures and the paint the students have made. And so our first question is, how many different shades of paint did the students make? So if the ratios are exactly the same, then they're going to make the exact same shade. You're just going to get like more of it, right? So what we need to do to figure out how many different shades there are is analyze and look at the ratios that we have here and put these ratios in simplest form, okay? And so we could do this where we make them like how many yellow to blue, or we could do yellow to total or blue to total. But let's just go with ratios of yellow to blue, okay? So if that's the case, then this is stop it. We don't want that one. Let's do it. Let's do it in blue. And I'll do that. So this is going to be a 1 to 2 ratio, correct? And this is a 2 to 3 ratio. This is a 3 to 6 ratio, which 3 out of 6 is the same as 1/2, right? So this is also going to be a 1 to 2 ratio. This is 4 to 6 ratio, which when you simplify that, goes down to a 2 to 3rds ratio, which is 2 to 3. And then this one is a 5 to 8 ratio, and this is 6/9, which simplifies down to 2/3, which is a 2 to 3 ratio. So with that being the case, take a look at these and decide how many different shades of paint we have. I'm going to go ahead and pause that, and then when you are ready to declare that answer, go ahead and declare the answer and then unpause. All right, so what did we notice here? Everything that has the same ratios will be the same shade. So here is a ratio that's the same as this ratio. Are there any other shades that have a 1 to 2 ratio? It doesn't look like there are. Now let's go for the 2/3 ratio. Here's a 2/3, here's a 2/3, and here's a 2/3. So that means you've got 3 different paints are the exact same color paint, same shade of green. It's just these have more paint than this, and this has the least amount of paint. And that leaves us with one more ratio, which would be the 5 to 8 ratio. So looks to me like if you answered that there are 3 shades of green paint, you got the correct answer. All right, so some of the shades of paint were bluer than others. Which mixtures were the bluest? All right, so now I'm going to go ahead and erase all this. I'll pause while I do that. I'll come right back. All right, that's nice and clean. All right, so I guess what we need to do here is some shades of paint were bluer than others. Looking at these ratios, which ones have the highest percent of blue paint in their ratio? That would be an indicator that they would have a more blue shade than the others that have a less percent of blue. So the more yellow you get, the paler the green color is going to be, going toward a yellow hue, and the less yellow and the more blue, the darker the green is going to be, going toward a blue hue. So now's where you want to kind of think of totals. So actually, let me change that color there so we don't confuse it with our answers down below. Let me do this like that. Let's look at our totals. So in this case, you got a total of 1 part that's yellow and 2 parts that's blue. That means you got a total of 3 parts. This one has a total of 5 parts. This has a total of 9 parts. This has a total of 10 parts. This has a total of 13 parts, and this has a total of 15 parts. So what I would like for you to do now is write a fraction of the total number of blue parts out of the total number of parts and write those ratios below here. And then we're going to find out what the percent equivalents are for each one of them. Okay, so I'm going to pause. You go ahead and pause, and then we will answer this question below of which mixture would be the bluest. Okay. Okay, so let's do each one of these parts one at a time. So paint A has 2 parts blue out of the 3 total. So if you were to write that as a fraction, it would be 2/3, which is the same as 66.6% or 66 2/3% blue. Paint B has 3 out of the 5 parts are blue, and 3 out of 5 is 60%. Paint C is 6 out of 9 parts is blue, so that would be the same as paint A, which is 66 2/3% or 66.6 repeated percent. Part D has 6 out of 10 parts that are blue, so that's 60%. Paint E has 8 out of the 13 parts that are blue, and 8 out of 13 is a big long repeating decimal, but I rounded it to 61.5. And then paint F is 9 out of 15, which simplifies down to 3 out of 5. So that'll be the same as paint D and paint B at 60% blue. So looking at these, it looks as if paint A and paint C have the highest concentration of blue paint at 66 2/3%. So they will be the bluest paints. Now, carefully plot a point for each mixture on a coordinate plane like the one that is shown in the figure. Okay, so you'll want to copy this down. So make the x-axis equal to the, or have it be the number of yellow parts, and the y-axis will be, or the vertical axis will be the number of blue parts. And what we're going to do is we're going to take each one of these and we're going to plot them and see what we get here. See what kind of lines they form. Okay, so let me pause for a second and get this set up. Okay, so as you're making the graph, if you have coordinate grid paper, that would be ideal. If you're doing it from a print off from this, I just decided to count by ones on the x-axis, and it has to go all the way up to 6 because that's the greatest number of yellow parts you're going to have. And on the y-axis, the vertical axis, I needed it to go up to 9 because that's the greatest number of parts we have there. And so what we want to do is try and find these approximate locations. So I'm going to take this ratio of yellow parts to blue parts, and we're going to think about those in terms of an ordered pair. So let's start with paint A, which would be at where you have 1 part yellow. And in fact, let me color coordinate this, because what did I do? I put those in green, right? Yes. So let's put this one in green. So if it's 1 part yellow and 2 parts, this is going to be paint A. I'm going to label that as an A. And paint B, I color coded that in blue. That was 2 parts yellow, 3 parts blue. So 2 parts yellow, 3 parts blue is going to be right around there, and that's going to be paint, or that's going to be B. And what is the third one? The third one is in green, so that is 3 parts yellow, 6 parts blue. So 3 parts yellow, and then that would go right around here, and that's going to be paint C. And then D is blue, so that's going to be 4 and 6. So yellow is 4. Did I get that right? Yes, I did get that right. So this is going to be 4, and it's 6 also. So that should be even with this one, and we're going to call that point D, because that's paint D. And then E was at 5, 8. 5 parts yellow. I'll do this in black. 5 parts yellow and 8 parts in blue, and that would be E. And then the last one was paint F, which was 6 and 9. This is getting a little bit tricky, so I'm going to do this. I'm going to go where the 9 is, bring that out to here, and the 6 goes up to here. And so the intersection point for this one, and that was in blue, right? So let's put that right there. You know what? That's not a bad idea. Hold on for a second. Does this one look like it's at 5, 8? Yeah, that's pretty good. Does this one look like it's at 4, 6? Yeah, that's pretty good. And this one looks like it's at 3, 6. Yep, that's pretty good. And this one looks like it's at 2, 3. Okay, that's all right. And this one looks like it's at 1, 2. All right, I feel pretty good about all of those locations. I just need to label this last one because that was paint F, which is right here. So actually, let me do something. Let me move these guys, put B below, and let's put B below because we're gonna draw a straight line. All right, so carefully plot each point and mixture like the one that is shown in this figure. All right, so then the last part says, draw a line connecting each point to 0, 0. What do the mixtures that are the same shade of green have in common? So let's do this one in green. We'll start right here and color this green. All the ones that are green would go through there. Let's do the ones in blue. We're going through there. Is that right? I think those are about right. I think this one probably needs to move over a little bit. Wait, hold on. Let's move this guy up a little bit. That's about right. And then this one, which one was a little bit higher? Yeah, that one's supposed to be a little bit higher. Should be right around there. That's where it should be. So this one is the last one. It goes through there. So what are we noticing here? What we should be noticing is that all of the, actually, hold on for a second. I'm going to pause and I'm going to let you see if you can draw the connection, and then I'll reveal the answer, because it's not good for me to just tell you what the answer is. You got to try and figure it out on your own. But what do you notice there? What do you notice there? Hold on. All right. So what do you notice about points A and C? They're all on the same line, right? And what did we say? Why did we color coordinate those green? Because those are the same shade of green. They happen to be the one that has the highest concentration of blue paint, but they are the same exact shade and they're falling on the same line. Then look at points D, B, and F. What do you notice about all of them? They all have the least concentration of blue paint. They are 60% blue paint and 40% yellow, and they all fall on the same line. And then there's only one paint that was 61.5%. Notice how it's a little bit above the blue line, but less than the green lines. The green is the steepest because it's got the highest concentration of blue. The blue line is the least steep. That's got the least concentration of blue at 6%. And then the one in the middle is the point E, falls on the black line. So what do they all have in common? All of those points. Stop it. Why? Don't do that to me. There we go. All the paints that are the same shade of green fall on the same line. Okay, so this is kind of giving you an idea about equivalent fractions and equivalent ratios and proportional reasoning, doing the simplifying, and this is kind of showing us, giving us a glimpse at all of these proportions that are set up, all of these ratios. If you graph them, they pass through 0, 0, which is one of the big keys that we're going to be looking at as we get into proportional reasoning in our next lesson, okay? Or once we eventually get to lesson 4.2.1, which is in the year 2020, we're doing this tomorrow, okay? So go ahead and clean this up a little bit. This would be something for you to keep, that might help you as we march toward our Chapter 4 test, which is going to be about proportional reasoning, and this is just one application of proportional reasoning. All right, take care, bye.
Hey, feeling good.